So here's an example. It reads, two angles in standard position are called coterminal angles if they have the same terminal ray. For any given angle, there are infinitely many coterminal angles. Excuse me. The example is find two angles, one positive and one negative, that are coterminal with pi over 4. So I think the first thing we want to know is, where is pi over 4, right? So remember, we have 1 pi radians right here. So pi over 4 would be 1/4 of this right there. So that's a pi over 4 angle. And now I want to identify one positive and one negative coterminal angle. So visually speaking, a positive coterminal angle with pi over 4 would be one full rotation of 360 degrees, or in this case, 2 pi radians, plus this existing pi over 4 angle right here. So I would start at 0 radians, go around unit circle, one full rotation, so that's 2 pi radians right now, plus that pi over 4 there. So that worked out would be pi over 4 radians plus 2 pi radians in that case, right? So we're gonna do this real quick. You want to keep it as fractions, not turn things into decimals with your calculator. So I'm just gonna produce common denominators on this one, which is 4. Right? So that's gonna lead me to adding pi over 4 radians plus 8 pi over 4 radians, and that's going to give me 9 pi over 4 radians. So that would be your first positive coterminal angle with a pi over 4 radian angle measure. And then also, we need to do this for the negative version of this, right? So let's separate that. And then for the negative version, instead of rotating in the counterclockwise direction, we're going to need to rotate in the clockwise direction. So let's get that out of there. And so we would start at 0 radians. Actually, I think in this case, you should start where the angle is, pi over 4. So we start with pi over 4, and then we subtract one full rotation, right? So we're going to start here and then rotate in the clockwise direction. So I'm going to go all the way around to there. Okay, I paused the video there for a second because I noticed that my diagram here for the spiral, I went further than I wanted to, so I'm just going to get rid of that and go back to what I was saying. So we're going to start with our pi over 4, and then what we're going to do is we're going to rotate in the clockwise direction from pi over 4 radians. So we're going to go like this, all the way back around to there, right there. So what's that going to do for us is we're going to start with pi over 4, and then we're going to subtract a full 2 pi angle from that. And again, with common denominators here, that's 8 pi over 4. So I multiply this by 4 and 4, giving me pi over 4 minus 8 pi over 4, which is a negative 7 pi over 4 radians. So now that's my first negative coterminal angle from an angle of pi over 4 radians right here. Okay, so what I've found in the past is students kind of struggle with the concept of what a coterminal angle is, and then once they make sense of it, identifying coterminal angles is pretty basic at that point. In fact, our introduction of the unit circle yesterday, we identified quadrantial angles, and specifically, I'll just head down here on the unit circle, right? We were going around and identifying, I'll do it in degrees because it's a little bit easier. We said 90 degrees, 180 degrees, 270 degrees, 360 degrees, right? But 360 degrees is also coterminal with 0 degrees. And we did that yesterday without really thinking much about it or even referencing it as a coterminal angle. Excuse me. But once you make sense of it, it's pretty basic from that point forward. Okay, next example is, let's read this really see it. Find two angles, one positive and one negative, that are coterminal with the angle negative pi over 3. So again, figure out where negative pi over 3 is. That's approximately negative pi over 3 right here. So I want a positive coterminal angle. So what I'm going to do is I'm going to start with that negative pi over 3 angle, and I want to go one full rotation from that terminal side, or terminal ray. So I'm going to add 2 pi radians to that. Again, we're going to make common denominators here. I'm going to multiply 2 pi radians by 1 in the form of 3 over 3, giving me negative pi over 3 plus 6 pi over 3 radians, giving me a positive angle of 5 pi over 3 radians. So this is your first positive coterminal angle with a negative pi over 3 angle, and then we want a negative one, right? So again, same thing. We're gonna start at our terminal ray here, and then I'm just going to subtract another 2 pi radians, right? So we'll start with negative pi over 3, and now subtract 2 pi radians. I've already have my common denominators created, so I'm just going to jump to that line. So I start with negative pi over 3 minus 8 pi over, excuse me, not 8 pi, 6 pi over 3. And that's going to leave me with a negative 7 pi over 3 coterminal angle with a negative pi over 3 radian angle there. So again, both the green and the red angles that we just identified here and here, they both share the exact same terminal ray as the negative pi over 3. It's just how many rotations about the circle we went. And then one more. I think there's one more. So this is a pi over 2 one. It's a little bit easier. There's pi over 2. And again, this is actually not the same question as the previous ones. This one is actually asking us to consider a pi over 2 angle. And we want to try to produce some type of expression to represent, this is critical here, all existing angles, right? So here's my pi over 2 positive angle. And if you think about it, every time I move, rotate in the counterclockwise direction, 2 pi radians or 360 degrees, I'm back at the exact same angle again. And we can continue to do that. We can just keep adding 2 pi radians each time I go around the circle. But if you think about it, our initial angle is pi over 2 radians right here. So we're going to start with that initial angle, pi over 2. And for each coterminal angle, I add another rotation of 2 pi radians to that. So I know I'm going to be adding 2 pi, right? And then how do I express that for all angles? Well, what we do is we introduce this integer value. It's a variable, n, where n is an integer value, only integer values, and n can be positive and negative. And n indicates, I'm going to just write that down, let n be all positive, all integer values, not positive or negative. And that's positive or negative. So if I wanted to find a coterminal angle 3 rotations away from pi over 2, I would say, let n equal 3 and substitute 3 into that n, and I would multiply 2 pi by 3 and then add that to pi over 2 radians, and that would give me a coterminal angle with pi over 2. But in summary, this expression right here, pi over 2 plus 2 pi n, this is a generalized expression that will identify all existing coterminal angles with a pi over 2 radian angle measure. regardless of which direction you're rotating, because n, right now, n can be any positive or negative integer. So I could say, you know, in the negative zone, so then I would change 3 to negative. And that would be 3 rotations clockwise away from pi over 2 radians there. I think that was it. Yeah. Okay, so let me pause this.